Hello. In this part, we would like to introduce some important identities. First, let's consider this figure. This is an L-shaped figure, and dimension is like this. And if you want to find the area of this shape, in the L shape, in the left-hand side, we can fill in the L shape become the square in the right-hand side, like this. Assume that in the square, we assume that the largest square, the length is A, and for the smaller square, the length is B. Because the L shape is come from the larger square deduct the smaller square, that means we use the A square deduct this one, that means B square, such that the result become A square minus B square. And it is the area of this L shape. Now, we would like to use another approach to find the area. In this L shape, we find that the longer side is A and shorter side is B. Now, I would like to, from here, I cut into two parts. It's because it's B, then this part become A minus B, and it's B. Of course, this one also A minus B. That means these two are the same. Now, I cut this small rectangle and combine in here, such that become a larger rectangle, and the side is A minus B, and it's A, and combine this is B. So we find that the longer side become A plus B, and because it is a rectangle, so for the area, just the product of these two, that means that is A plus B times A minus B. In this two method, because we are talking the same L shape, that means that these two areas are the same. That means that when A squared minus B squared equals to A plus B times A minus B, and they are the same. So this one is become the identity. So in general, when I give you A and B here, then we know that when A squared minus B squared, it will equals to A plus B times A minus B, and this one called difference of two squares. Except we use the graphical format, we can also use the algebraic method to. Except we use the graphical method to find the difference of two squares as an identity, we can also use algebraic method to prove the identity. Let's see here. Now, let's expand the right hand side. When A plus B times A minus B, like this, right? By expansion here, we become A squared plus AB minus AB minus B squared. Now, you find that these two can be cancelled. That means remain A squared minus B squared. That means it's the same as the left hand side. And so, from this one, we can prove that when A squared minus B squared, it will identical to A plus B, A minus B. Now, after we learn the identities, we would like to use these two in some examples. Let's go back here. We know that when A plus B times A minus B, we know that it will identical to A squared minus B squared. It is the identities we learned before. Now we want to use this to solve the following problem. The first one, when I say y plus 2 times y minus 2, Then, when you consider this one, you find that both is y, and both is 2. And one is plus, one is minus, okay? So, when you compare these two, you find that just the a replaced by y and b replaced by 2 only. Such that you find that is the something plus something and something minus something format. So you know that this one, you can say that it is in a plus b and a minus b format. Just because these two are same, these two are same, and 1 plus 1 minus. So this one is the a plus b, a minus b format. And if you meet the expression like this, then because you know that is the a plus b, a minus b format, that means you can treat y as a, so it's y squared, and b treat as 2, so you know that is 2 squared. As a result is y squared minus 4. Let's see another example. When I say 3x plus 1 and 3x minus 1, okay? And when you compare here, you find that both is 3x, and this 2 is 1, and 1 plus 1 minus. As a result, it is also the a plus b and a minus b format. Okay? But this time a replaced by 3x and b replaced by 1 only. Okay? And because you know that the a replaced by 3x, that means the a should replace by whole 3x, right? Whole 3x. And because it's the a plus b, a minus b format, and you know that this one can become a squared minus b squared, so we can use this to expand it. Well, so 3x as a, so become 3x squared. And because it's a squared, a represents the whole a. So when I say 3x, that means that the whole 3x takes square. And the b replaced by 1, so become minus 1 squared. As a result, is 9x squared minus 1. And we consider 2a plus 5b and 2a minus 5b here. And when you compare this one with this one, okay, you find that the a replaced by 2a, okay, and both of them same 2a, and b replaced by 5b. Okay, so for this one, when you compare this one, you find that these two are same, these two are same, okay, and 1 plus 1 minus. So you find that this one also the a plus b times a minus b format. Only a replaced by 2a and b replaced by 5b. So from this identity, that means that when a plus b and a minus b format can become a squared minus b squared. So in this expression, you can this 2 just like a, so become 2a squared. But don't forget, a is a whole a, so that means the whole 2a takes square. And b squared, right? In this one, and this one become 5b. So when in this format, it is this square, so with this square, so 5b squared. The same, the b means a whole b, right? Everything in whole in the b, right? So in the b can be the term like this. So when this one is here, then it should be the whole takes square, and minus, that means is 4a squared minus 25b squared. Now, we would like to talk this example. This time, it seems that it don't look like the any a plus b, a minus b format. But now, because you found that both of them are the minus, now I would like to extract the minus, right? And that minus put to front. This one no change. And because the minus is taken out, so become m plus 1. Well, now, when you consider this 2, you find that is the a plus b and times a minus b again. This time a replaced by m and b replaced by 1 only, okay? And 1 plus 1 minus. So when you compare these two, is this one also the a plus b and a minus b format? Alright? And from And because you know that when a plus b and a minus c format can become a squared minus b squared, so that means that this one we can also apply the result, okay? But this time the a changed to m, so m squared, and b changed to 1, so become minus 1 squared. And we only take this two product only, so we keep the bracket and times minus 2 in future. That means m squared minus 1. And finally, you need to multiply with the minus 2 each, okay? Each. So as a result, become minus 2m squared and plus 2. Now, we would like to try this. Alright, this one you find that also the a plus b, a minus b format when you compare these two. But this time the a replaced by x, right? These two are same, and b replaced by x squared, right? And 1 plus 1 minus, so 1 plus 1 minus here. So you find that these two are the same format, okay? That means that this one can become a squared minus b squared, so something squared minus something squared. And this time a replaced by x, so x squared, and b replaced by x squared, so x squared squared, and minus, as a result, 64 minus x to power 4. In fact, there are some practical example here. Let's consider this. This time you want to solve 77 squared minus 73 squared. And you know that when a squared minus b squared, it can become a plus b, a minus b. Now you find that it's square minus square. That means we can apply this. And that means that a replaced by 77. So that means this a also replaced by 77. And is minus b squared become this 2, so that means become plus 73 and minus 73. As a result, when you sum these two, you find that 150, and when you consider 77 minus 73, you find it's 4. That means as a result, and you know the product, so that means that after these two take the calculation, it's just the same as 150 times 4. Now you can quickly give me that result is 600. Now consider this one, okay? This time when you calculate this product, you find that it's a long time, okay? And it's not easy to calculate by hand. But now you find that both of them are close to 100. Now let's see here. 196, you find that can become 100 minus 4. Okay? 104 here, when you compare 100, you can become 100 plus 4. Alright, after you write this, you find that this one only equals to 100 minus 4 times 100 plus 4. And when you compare the a plus b and a minus b, you find that the same format. Only a replaced by 100 and b replaced by 4. Okay? And because it's identity, we can become the a squared minus b squared when I have the a plus b, a minus b format. So this time a replaced by 100, that means 100 square, and minus b squared, that means 4 square. That means that is the 10,000 deduct 16. As a result, is 9984, 9,984. In fact, there are some more examples here. Alright, for example, is that when x plus 2 times x minus 2, right, because the same is a plus b, a minus b format, so you find that a replaced by h and b replaced by 2, so as a result is x squared minus 4. And in this example, when I compare these two, you find that it's the a plus b, a minus b format, but this time a replaced by 2x and b replaced by 3y. So that means by identity you can replace 2x by a in a and replace 3y in b, right? That means that become 2x squared minus 3y squared. As a result, is 4x squared minus 9y squared. And here are some for example, and you can read by yourself. And also we can use, just like before, we use the identity to solve some expressions. And when square minus square, you can become the a plus b and a minus b format. Then you find that the calculator is faster. The same way, when 198 times 202, you find that one is 200 minus 2 and one is 200 plus 2. So you can become 200 squared minus 2 squared. You can have this result. So these are the 4 questions. We also demonstrate in some examples before. So this one can read by yourself. Now we finish the a squared minus b squared part. Okay. So your job, having to do the quiz in Moodle after read the video, and also you can do level 1 questions in textbooks exercise 2B. Thank you and bye bye.